Okay, so here we're going to use the product rule to differentiate the function. And then after we figure the derivative out using the product rule, we're going to algebraically manipulate the function so that we can take the derivative without using the product rule. Namely, we're just going to multiply it out. Okay, so let's work through this. What's the product rule say? It says the first times the derivative of second plus the second times the derivative of the first. Okay, so the first times the derivative of the second. What's the derivative of the second? Well, the derivative of 5 is 0. Derivative of 4x is just 4. Okay, plus the second, which is 5 plus 4x, times the derivative of the first. Well, the derivative of 3x is 3, and the derivative of negative 2x squared, well, the 2 comes out front to make it negative 4, and then subtract 1 to just make it x. So now we have this piece and this piece, and what amounts past this is algebra. We got to simplify. So here I'm going to distribute the 4. So 4 times 3x is 12x. And then 4 times negative 2x is negative 8x squared. Okay? So I should have said negative 2x squared, but that's all right. All right. Now I'm going to add. So here I need to do FOIL. So 5 times 3 is 15. And then 5 times negative 4x is 20x, negative 20x. And then I have 4x times 3, which is 12x. And then 4x times negative 4x is negative 16x squared. Okay, so I'm going to collect like terms here. I have negative 24x squared total because that's negative 8x squared, and negative 16x squared makes negative 24x squared. Next, I have 4x because whenever I combine all these x's here, those add up to 4x. And then there's only one constant, 15. So it's plus 15 there. So that's my final answer here using the product rule. But now I want to multiply this out so that I don't have to use the product rule. So I'm going to start, instead of using the product rule here because it's multiplication, I'm going to go ahead and multiply this out. And so that means I'm going to FOIL. So first outer inner last. So that's looks like 15x. And then multiply by 3x and 4x, make 12x squared. And then negative 2x squared and 5 make negative 10x squared. And negative 2x squared and 4x is negative 8x cubed. So simplifying, I can combine those two like terms. They both have the same DNA. And so that's minus 2x squared here. I got my 15x there, and then drop down the negative 8x cubed. Now that I have this, I'm going to take the derivative of it, and I just used the power rule. The derivative of 15x is 15. The derivative of 2x squared is 4x, and the derivative of negative 3x cubed, well, negative 3 times negative 8 is negative 24, and then subtract 1 from the exponent gets me x squared. Okay, and as you can see here, they are equivalent to each other. Negative 24x, negative 24x, 4x, 4x, 15 and 15. Okay, and that proves what we were trying to set out to do. So you might be thinking, well, why don't I just multiply this out, right? Why don't I just multiply it out? Well, sometimes it's just not so easy to do. What if you had something like sine x times x plus 2, right? So even if you multiply that out, that's sine x multiplied by x, right? Plus 2 multiplied by sine x. So you still are forced to do a product rule there even after you do distribute everything. So even though you multiply it out, you still can't get around having to do the product rule. So you really have to know the product rule to keep going further in this.